Record to cloud.
Okay, well, welcome to the July 12th, 2022 session of HAM-SCI and Tangerine SDR technical session.
Check
My
the
name is
date.
Dave, KV0S, and this week I've been continuing to reorganize my computers a little bit and played with GNU Radio, listening to signals and decoding them and trying to teach myself more about using GNU Radio. So that was a bit of what I did this week. So that's it for me. Next on the list, we have Nathaniel, W2 NAF. Go ahead, Nathaniel.
Thanks, Dave. It's been a very busy week for me. I'm continuing to work with all students on different projects. Let's see, we have, I'm also part of this MSTID International Space Science Institute meeting, which means I'm supposed to be in Switzerland right now, but I'm here in Pennsylvania, and I'm attending the meeting virtually and getting up around 2:30 in the morning to do that. So that's making my schedule a little bit more interesting, but we're surviving. The weather's nice. I got to work on the trails a bit today. I'm trying to redo some plots for Christina's paper. W2NF, back to net.
Well, very good. Next on the list is Bill, AB4EJ. Go ahead, Bill.
Hey, fine business, Dave. I've been going through with the central control system and adjusting it to be able to handle various different kinds of uploads. I've got it to where it will handle the grade correctly. I already had it where it will handle the simulated Tangerine uploads, and I've been working on getting the magnetometer data to upload. One peculiar thing about the magnetometer data is the way the magnetometer package works is it wants to write to a file once per second. And many of the uploader programs, LFTP, SFTP, those kind of things, interpret that as being a continuously open file and never complete. So I'm working with Dave Witten on this. We're going to cook up some solution. One thing that I have done that seems to work is I went into the program and changed the code so that rather than outputting a magnetometer output every second, it puts out a magnetometer, a data point every 10 seconds. And, you know, this is not a rapidly changing thing where you have to get a point every second. And that kind of seems to sort of work most of the time, but we may have to do something more sophisticated with some kind of a queuing system or something like that. I'd like to get the data every second if we can. So maybe maybe MSMQ or something like that. But anyway, Witten and I are working on this, and Witten is lucky dog. He's stuck in Dallas. He went to Santa Fe, and he was halfway back, and all the remaining flights were canceled. So he's stuck in Dallas. He thinks he might be able to get home by about 4 a.m. tomorrow. So he's not a happy camper. Yeah. Anyway, so we're working on that. It's not a simple problem, but we'll figure it out. Anyway, back to net.
Very, very good. Next on the list is Jules, K2 KGJ.
Oh, good, Dave.
Well, let me tell you something, Jules. My father's initials are KGL.
Oh,
and that always throws me off.
I can believe that. Sure. Well, this has been sort of a major cleanup. This week is major basement workshop and cleanup, getting rid of years old magazines, all sorts of other stuff, some old test equipment that has no value. So it's been a lot of work, grub work this week, but it's looking better. and the more I can get rid of, the better. The other thing I was going to mention, that with the magnetometer data, typically Hillman and I both use a 1 minute sliding average as the actual data that we plot. So it may be possible, and again, Dave may have some preference for actually collecting stuff at a shorter interval, but you might want to talk to Hillman about this as well in terms of what's useful. And it may be possible to actually do that averaging on the Pi and then just send data every minute. But that's another possibility. I
can tell you that there are cases where 1 second magnetometer data is useful. I think that, yeah, so definitely 1 second magnetometer data can be useful, I think.
What kind of resolution though? We're talking about events that will have to exceed 5 nanoteslas to be seen though, Nathaniel.
Yeah, that might be the trick though. So it may not, you may need more integration time.
Yeah, I've been able to catch all of the CMEs so far, that the near misses so far with that 1 minute average. So,
well, what you're interested in are these things called ULF waves.
Okay.
And so ultra low frequency waves, and they can range in, they can go as small as like, fractions of a nanotesla, but they can, be bigger than, 10 or 20 nanoteslas as well. And I can get you the article that gives you the range of frequencies for ULF waves. They typically put them in different bands. I'll post an article in the chat.
Yeah, that'd be handy. Bands. Yep, thank you.
So, say I would like a question. Could you or Dave or somebody give us preferred settings for the run mag command?
Oh,
the defaults.
Yeah, Dave and I have been trying a few. I typically go for a higher cycle count, and I also use the averaging capability, which is the So
I'm
yes,
using. Oh, excuse me.
No, go ahead.
I'm using something that you suggested about 2 years ago. So
okay.
And it's been running continuously on that setting, but I would like to know what the current recommended setting is.
Sure, I'll look at the Pis, the 2 Pis that I have running, and see what I'm using currently on that. Sure.
Yeah.
So in the chat, I put in it's not a paper, it's just a website about ULF waves, and they typically break magnetospheric ULF waves down into different bands. Here, I'll just share my screen for a second. So you have the PC bands, which means pulsations continuous, which are more like regular sinusoidal types of pulsations. And then you also have PI type pulsations, which are impulsive. So they're less continuous or more impulsive. But here you can see the periods that you're interested in can get as fast as between like 0.2 and 5 seconds. So you presumably want to be sampling twice as fast as that. So for some of these, PC1, PC2, PC3, you probably want to be doing better than a minute sampling. And so that's where, a 1 second cadence is usually plenty adequate for this. Of course, that's provided you can make the instrument not be too noisy and you can get adequate resolution. And you can see they list the amplitudes here too. So you can see that these faster waves also tend to have lower amplitudes that are well below what we expect our magnetometer to be able to handle. So when you start getting into PC3, this looks like it starts to be about where we might be able to make some measurements. So, but this is, you might want to keep this chart in mind when you're doing some of the testing and making some decisions.
Well, one of the things that one of the advantages we have with this is that the amount of data being collected is really not that huge. So
Yeah.
you could store a minute's worth of readings taken at 1 second intervals in the memory and just spit it out to disk once a minute.
Right.
And
Yeah.
that would allow my uploader program to be able to, in the interval in between those, be able to upload, because it only takes a second or two to upload that amount of data. The
Yeah.
problem I'm having right now is that you're keeping the file open all the time, and the uploader program says, well, I'm going to wait until he finishes and closes the program, closes the file, and the file never closes. And
Right.
then even if I tried changing the program to open and close every second, well, because of the amount of time it takes to do the open and close, it's still interpreted by Ubuntu operating system as being open continuously. So, but yeah, we'll figure it out. I mean, Dave had some ideas what you could do with a pipe and some things like that. We'll figure something out. But if 1 second measurements are useful, we will figure out some way to get them.
Okay. I don't know. And yeah, they don't necessarily need to be in real time. I mean, if you're doing 1 minute cadence upload, I think that's plenty real time for, most applications that we would need. So, and then having that 1 second cadence for post processing could be useful
Right.
for scientific
Yeah,
applications.
I don't know that we necessarily even have the capacity in the server to be able to handle a whole bunch of people doing a 1 minute, a 1 minute cadence of, I mean,
Yeah.
I was thinking more like 15-minute, a 1 second interval on the measurements, but
Yeah.
upload every 15 minutes, something like that.
Yeah. 15 minutes is probably good. If you could do 5 minutes, that's probably nice.
So, I mean, we'll see how far we can push it. I mean, we at some point we may have to talk to NASA or somebody or NSF about more money for a bigger, faster server, but we know that. I mean,
Yeah.
if we start getting 1,000 users on here, what we have at the UA is going to be overwhelmed. You're going to need to see something for Amazon Web Services or
Yeah.
Google or Microsoft Azure or somewhere. Somebody's got a big server farm, bigger than what we have.
Yep.
I mean, if you have the funding, you could put something in at U of Scranton too. I mean, if you want to build a system to do this, if you can find the funding, absolutely.
Yeah.
We can support that too.
Okay.
So.
Yeah.
I guess we should go on down the list. So next on the list, I think, is Dan in for XWE. Go ahead, Dan.
Okay, thanks, Dave. Good evening, everybody. In the process of moving, and that's taken up about all of my life the last week and a half or so. Worked on scripts a little bit and trying to make sure that everything's upgraded to the last iteration of RASMeet OS, and that's about it from here. Back to you, Dave.
So you moving to Huntsville, is that right?
No, I'm probably moving to the Athens, Tennessee area. I'm not really sure 100% what's going on. I'm in Huntsville right now.
So, okay. Well, next on the list is David, N1 HAC. Go ahead, David.
Good evening, everyone. And I've got a different background right now. Just had a Clan McFarlane board meeting. Loch Sloy, that's our battle call. Well, it's been an interesting week. I'm working on finishing up our Baffin Island project. That's getting everything up to University of New Brunswick, who will install it up in a couple of sites on Baffin Island. And that's supposed to pick up conjugate waves from South Pole. That's why it's being sited there. And then continuing to work on Yeoman's the Korean Ego project to be sited down this season. And then amateur radio, we had a big event over the weekend called the Proudy. It's a fundraising event for a local cancer center. And I don't know how many riders we had. It's a 100-mile, actually it can be as much as a 200-mile bike ride, 2 days for those who do that. The last one we had before COVID was 3,000 riders, $3 million raised. I don't know how many riders we had. It was down a bit, but they raised $5 million somehow. So it's a big event for us. We use several repeaters linked together, and we're the ones doing the radio communications, trying to keep track of people and keep them safe. Started from 4 riders almost, well, it was 40 some odd years ago, and it's grown to be quite an event. So that always brings the hams out of the woodwork, and we get people
Yes.
from all around northern New England covering this. It's centered in Hanover, New Hampshire. So back to Net.
Well, very good. Congratulations on that event. Next on the list is James, KG4 DSG. Go ahead, James.
Evening, Dave and the group. Not much to report here. I do have a question for the discussion about the open HPSDR, but it can wait for now. Other than that, just trying to stay cool and stay dry. Back to the net.
Okay. And next on the list is Jay, WB8 SBI. Go ahead, Jay.
Yeah, good evening, everybody. Not a whole heck of a lot new here. Frankly, nothing new here. Just a general question. The Digital Communications Conference upcoming, is it going to be both in person and online? Anybody have any information?
I have a little information. The current plan is that it will be in person with a YouTube stream, but not a Zoom. I don't think there's a plan for Zoom unless maybe some speaker has to Zoom in to give their talk or something. But the audience participation will be on YouTube, because we have to depend on the bandwidth of the network that we can acquire at the hotel.
Okay.
And that's the big constraint.
Okay. Well, otherwise, hope everybody had a good field day, and take care, and we'll catch you later on down the log.
Yes. I will mention that I believe Tom can confirm this. Some of the hotel reservation information, it should be on the website by now.
Great.
So,
Yeah, as of this moment, I can only attend online.
Yeah.
So, however, that's good to know that there will be an online way to listen in.
yes.
Okay, that's it. Take care, everybody. Stay safe, stay cool. Back to net
Oh.
control.
Second,
Oh.
appreciating that it'll be online.
Yes. Next on the list is Jonathan, KC3 EEY. Go ahead, Jonathan.
Hi, everybody. I had quite a busy couple of weeks. I'm currently working on 3 different projects at once, trying to order, get all the parts I need from DigiKey, and then realizing I need more. Then I do more assembly, and then I realize I need more parts, this and that. So, but what I've been working on is I've been working on my amateur VLF transmitting rig, my EBNOT rig. I've been working on the mechanical mounting of the Raspberry Pi and the sound card and the GPS in a enclosure. I'm still waiting on the DC-DC converter and SD card for the Raspberry Pi. The second project that I'm working on is the 3-channel VLF capture system that's very similar to the system that I built in 2020 that's installed at Nathaniel's house now. But it will capture 3 channels, 1 E field and 2 H field channels. I got all the drilling done in the enclosure, and right now I'm building up the interface PCB that'll provide power for the whole box, and power for the receivers, and lightning protection, and it'll pipe the or it'll interface the audio streams to the sound card. So I'm working on populating the board and everything else. And the third thing that I'm working on, I actually just recently started it, is the H field receiver. This is the dual channel receiver. Actually, it's 2 receivers, which will connect to loops. There'll be about 25 square foot loops made with 14 gauge Romex. It's gonna it'll be the wires will be connected together, and it'll make a loop of 3 turns, and that's going to be the loop antenna for the H field receiver. So I just got done drilling out the holes for the cable glands in the enclosure. So what I have to do next is I have to cut the copper clad board to the right size, and drill holes for mounting, and then I have to drill a couple holes in the copper clad board for raised pieces of perf board that will act as or that screw terminals will attach to. So I'm making pretty good progress with that. Another good thing is I spoke to Morris Cohen with Nathaniel. He's at Georgia Tech, and his work has been VLF and Natural Radio for many years. In fact, he was part of the system design of the awesome VLF receiver. I don't know if any of you know about that, but that was a fairly advanced project, similar to what I'm doing now. So
That's the Stanford project, I believe.
Yes, that's right. There might be some partnership going on. We discussed a plan to develop a kit, a VLF receiver kit that volunteers would build and install in their rural backyards, and that would be designed by Morris's group, and I will be working on the back end. The current plan would be using Raspberry Pis and sound cards, although Raspberry Pis are hard to get right now. I actually do need a Raspberry Pi 3B, but the only place that I could find one is Newark, and they were on back order, and I believe the end of this month they'll ship, but I have to check that. And then eventually we plan on having a network of VLF receivers. So this is part of my plan to have a network of VLF receivers feeding spectrum data back to a server. So it's fairly exciting. If he wants to go through with this, if what we're offering can work with his needs, then it'll be really cool to do. That's all I have. Back to the net.
Well, fine business. And next on the list, we have Tom in 5EG. Go ahead, Tom.
Good evening, Dave, and everyone in the group. No effort on the project the last couple of weeks. I did see the registration link for the hotel show up for DCC. I haven't seen the conference registration yet, but I'm sure folks are working on that. And from this far away and being in a small town, trying to locate airplane tickets is the hard part, and trying to get there in the same day can be a challenge. So not much. Quick question: has anyone talked to Scotty recently about the status of the adapter boards and where that is? Are we still waiting?
I talked to him last Thursday, and he said that he has to like turn them on and test them, and then he can send them out. And I told him I was on the phone with him and with Kung, and so I told him we were anxiously awaiting them. So I think it's close. I know he is under a lot of pressure trying to get his house cleaned up and ready for photographs to sell. I know he and Nona just had COVID again, and they had to put their cat of 18 years down last week. So they had a rough week last week.
Okay.
So, but I did tell him that we are anxiously awaiting the arrival of Kung cannot wait to get his hands on this adapter board and these RF and clock modules, and I can't wait to see them show up.
Yeah.
Well,
great.
and on top of all that, he's president of Tapper, and Tapper's had a lot of issues going on in the last couple of weeks related to DCC to get it pulled together.
Yeah.
Plans that we had laid changed.
I know that situation.
So I think we've got a solution for DCC that's going to work okay.
Yes.
All right. Well, that's about it.
I know we were so I saw your message too about the niche stack being removed. Yeah.
I managed to find the source document that we couldn't locate on the call a couple of weeks ago, and so I've talked with Kong. He's aware of it.
Yes.
And so I think we're going to be version locked in the 20 version series, and so that's okay. We'll work with that.
Okay. Sounds good.
So with that, I guess we're open for general discussion.
Can I ask my question?
Sure.
I was looking at the open HPSDR documentation that's out there, and I got a couple of questions. Number one, is Tangerine using that as a starting place, specifically Protocol 2? Is that correct?
No.
No?
Is that right, Tom?
Yeah. Dave's statement is correct. It's not using the open HPSDR protocol.
Okay. So the firmware that's in there for the open HPSDR really is not much help.
That's a true statement.
Okay. That's what I wanted to know.
Okay.
Yes. Basically, the Open HPSDR development was done the way it was because we were figuring out how to do it at the time, and the time was the mid 2000s, and considerable things have changed since then. But the trouble was, once it got started, it became difficult to just throw it away and start over.
Yeah. The only other comment I had was the HDL files apparently are in a Quartus proprietary format. They're not just text.
Yes, you do need the software to open them.
Yeah.
The trouble is, there were versions that were written in plain text, but the people who were keeping track of the code, when they uploaded to the repository, they just uploaded the
Quartus files.
Quartus files.
Can somebody translate those and post the?
Well, it's probably an old
Yes.
version of Quartus.
Yeah, I mean, but I mean, Tom and I have been fooling with some of those, but it can be done. We probably should do that. The problem was we went through a huge change in that we were developing and going along, and then we decided to switch out of SVN to Git at a time when SVN was declining and Git was, and the structures were hard to port that we had in the old SVN. So there is on the Tapper Git a reasonably complete copy of the old SVN.
Yeah, there is. I'm looking at it now. There is a open HPSDR-SVN repository on
Yes,
GitHub.
and that will have the directories from the old SVN. And then other things in the Tapper Git have been developed since that move.
Yeah, I was specifically, there's one for firmware specifically says it's Verilog code, but when you look at it, it's Quartus files.
Yeah, it's because the folks that were developing just uploaded their Quartus files because they had all the software, and they
Sure.
seemed like a rational thing to them.
But
Okay.
not good for posterity.
No, but it's a fair amount of work to do all that, loading all that software and then reading the files and then putting them back into.
Well, has anybody tried? Would those Quartus files load in an existing version of Quartus, or would you have to go back to the original?
I'm gonna guess you're gonna have to go back to the original.
Okay.
The Quartus has a few limitations. When devices become old and are no longer supported, they get dropped out of Quartus.
Yeah.
And I don't know if the Cyclone that was used on the Open HPSDR, I don't know if that's still supported or if its support dropped off. But there's a second issue, and that's that the building block files that describe the Verilog and other building blocks are modernized each version of Quartus. And in some cases, they're not forward compatible. And so Quartus is, in my experience, pretty version locked when you do things.
Okay.
Yeah, I wonder how we might approach that with the new design, trying to keep it openly readable for the future.
Yeah, it's probably worse with the new design than with the old design.
And another problem is that there are binaries that are embedded in Quartus that are used for some of the functionality. So you really are inputting information into a little black box within Quartus, And that's something that you'll never see.
Yeah. Well, even documenting just the basic functionality in some way, and not relying on, as we say, self-documenting code.
Yes.
Yeah, in Fortis, if you use the intellectual property that's built in, those are all black boxes. And the NEOS processor, the memory controllers, the DMA controllers, all of those things, the Ethernet interface, those are all very blockish. And I don't believe it cannot be read with the free tool set. The licensed tool set, you might be able to export the HDL. I'm not sure. That would be a question for Scotty.
I don't think you can, Tom.
Okay.
I'm working on a project right now that is using Fortis 2016, and we're kind of stuck in the same problem.
Right.
Yeah. Yeah, I spent quite a bit of time porting to version 20 of Quartus from the 2016. And all the design examples failed because of differences. And it required, basically just debugging what went wrong and then doing a whole lot of guessing. So it's the whole tool chain is quite opaque, actually.
I've got a question in regards to the testing. Is there any way we can offload some from Scotty? He seems awfully overloaded.
Well, I'm going to help him, I think, next month sometime. I'll be spending some time in the Phoenix area trying to get some of the testing done.
I'd really like to get
Is there anything-
some hardware to Kung very soon because I only have him for a few more weeks on the summer schedule. And then, I don't pay him anymore after that. So I might give Scotty a call again this week. But he said that what is it? He said like he might be able to get it out by this week, at least to Kung. He also said that he wanted to try and get it tested there. Easier to send it back to this.
I think he froze.
Looks like
There you are.
There you are. I think your internet connection stalled.
Yeah, I think so. So basically I was saying that, yes, it would be really nice if we could help Scotty out with this thing. He said that I'd really like to get a board to Kung sooner rather than later because I only have Kung for, a short amount of time more before the summer goes. So if we can get Scotty to get this moving, that'll really help. I know Scotty was concerned about sending the things out before he tested them because he said that if there was any problem, he could get it back to the CM faster for fixing. That was why he didn't want to just send things out. But if you have any suggestions or how to help, I'm definitely open to them. Because once we get the adapter boards out, I guess then we're really at the step where we can start trying to get to talk to the clock module and to the RF module, right?
Right.
Yeah, there's the developments in a state right now where I was debugging the drivers that talk to the SPI and I2C interfaces on the modules. And without hardware, of course, you don't get very far in that kind of a debug process.
Right.
So we have to bring up the drivers And then we have to start twiddling bits. Can we flip relays? Can we turn LEDs on and off? Once that works, then the next step is to actually start dumping the registers into the ASICs on the boards, which are on the order of 30 or 40 registers worth of content that have to be sent. Once that's done, then we have to somehow figure out how to take the fire hose coming out of the ADC and point it out the Ethernet spigot without going through the processor. So there's 3 or 4 steps that we'll have to take before we've got data we can interpret as something like ADC samples.
Mm-hmm. But as soon as you get the adapter boards and the RF and clock modules, you can start that process.
Right. We can start. The hard part is I've been away from Cordis now long enough that I think I have to go back through how does this work again?
Yes,
Part of
that's
the
the problem.
process.
Yeah.
There's a lot of steps in that thing, but I'm sure it'll come back quickly.
Yeah.
There are people here that have dabbled in it, but none of us work with it regularly all the time. So it's one of those things that takes a while to relearn.
Mm-hmm.
Yeah, when we're doing schematic capture on the receiver, I finally got proficient at it. And then we set aside the schematic for a year and I couldn't remember how to run the schematic capture tools again. So Scotty was kind enough I just sent him some chicken scratchings and he was able to get it done quickly.
So James, the short answer is we don't have a good answer for you.
Well, that's fine. I was just digging in just to see if there was anything I could gather. I realized that with later editions of FPGA design software that some of the stuff you probably did under the old Cordis is now integrated into the product. Specifically interfaces to hardware drivers and things like that. They probably wrap that all up and it wouldn't be that useful to fall back on the other ones.
Yeah.
I was just actually more interested in looking at the protocols, but you're saying you're not even using those. So it's a good place to look for information, but nothing that actually helps us going forward.
My recollection that Scotty said that the code on the Open HPSDR, didn't use a NEOS processor or a CPU of any kind. It was all
Yes.
Verilog. And my recollection is that the Verilog was in one single file that was
Yes,
like
it
137 pages.
Yes.
And so, it would be, I think, a challenge to use.
And unfortunately, a large proportion of that was just setting parameters,
Okay.
which is awfully boring code to try to read.
There is some limited documentation on what they were attempting to do, and it makes sense. And it doesn't surprise me that it was all hardware driven based on the block diagram that I saw. There was no processor involved. I give them great credit if they were able to do all of that TCP, UDP, packagization in just plain hardware, without any logic.
Well, that was the attempt under the open source banner.
Yeah.
Yeah, the advantage of that, of course, is you get away from a lot of the tool issues.
Yeah.
Versioning and things, but at the drawback of, you have to write an awful lot of HDL.
Yeah, it extends
Yes.
development a lot.
Yeah.
The tools are a big shortcut.
Yeah.
So are the interfaces between the black box code that you're integrating, are they well defined? You were talking about debugging some of that stuff. Is it bad documentation? Is it stuff that doesn't match up right?
Yeah, the blocks, there's a package called, used to be called QSys. It's now called Platform Designer in Quartus. And what that does is it allows you to drop the blocks into something resembling a schematic and wire buses and signals between the pins on the modules. They have a standard set of interfaces. They're called the Avalon interfaces that define how signals and streams and clocks and buffers travel between things. But from the documentation I looked at, the documentation just said, here's a block and here's the kind of stream it is. But there was a lot of important detail missing in the documentation.
Bad
And so
documentation.
when I tried to put the new versions together, there would be 7 additional parameter fields, none of which I could find any information about. And so I went through the try all possible values of all 7 fields until it started working approach.
Yeah. So,
So the documentation is, the difficulty with Quartus is that in my experience, over half of the documentation links are dead links.
Yeah.
And so it's really very challenging to try to pull together an adequate set of documentation.
Okay. Yeah, I earlier we're looking, the Quartus download site goes back to Quartus 13.
Yeah.
I don't know if it goes back any further than that, but that's all that's visible on the website. Back in 2013. So
Yeah. Altera kept up the design examples up through about 2016,
yeah.
Right around there. And then it seems like something happened and a lot of the really useful design examples stopped being supported. I think some go to like 2017 edition, but the really useful design examples stopped being supported after that, at least for some of the FPGA families.
And Tom, also that was when most of the existing code was compiled that's on the OpenHPSDR website was compiled with those either 16 or 17 versions.
Yeah, I had good luck getting 16 to work on Windows, and the binary installer for Windows came up and ran pretty well. The 20 version on Windows has got some broken things, and so I have to run it on Linux in order to the intellectual property blocks like the DDR3 RAM controller doesn't work on the Windows version, but it does on the Linux version. So there's issues like that kind of zeroed us into the Linux version 20. And then I was trying to jump back and forth between the versions, but was not successful. And I finally just bit the bullet and got it working, got one of the design examples working on Linux on version 20. And once that happened, we started making some progress. So I put in a new SSD into my desktop computer here and took out one spinning Rust, which had Ubuntu 16 on it. And I put Ubuntu 22 on the SSD and ran into an interesting little problem. Grub would work fine between the different Ubuntu versions, but when you boot Windows and you shut Windows down and you try to reboot the system, it wouldn't boot.
Right.
And the problem is that Windows forcibly changes the hard disk boot order.
Yes.
No matter what you put in, it changes it. And of course, Grub was on the SSD. And I finally solved it by setting a supervisor password in BIOS. And Windows doesn't know what that BIOS supervisor password is because I made up one. And that locks Windows out from being able to change the boot order. And then it comes up into a grub that I control, and I can bring everything up in the various ways that you want to do it. Kind of an unusual problem.
Well, that was, if I recall correctly, that was one of the selling points of moving to UEFI, was that there was a defined interface between the running operating system and the underlying firmware, so that you could do that.
Yeah.
Not that you should do that, but that you
Yes.
could do that.
Yeah.
Speaking SSDs, I have one that I just bought 3 weeks ago, decided to bite the bullet. Not a good sales pitch on the longevity that lasts 3 weeks on something that's supposed to last 3 years.
Yeah. Well, I ended up putting, yeah, go ahead. Was it, so it died after 3 weeks?
Yeah, it just started spitting errors, and I ran some
Oh,
tests
wow.
on it, and the error count just started shooting up rapidly. It's just a bad chip in there somewhere. And it's
Yeah.
going back under warranty. But I just like, I've had these things for years and never had a problem. And this one, 3 weeks and it's dead.
Yeah,
So,
I ran into a batch of USB sticks and had 100% failure rate on all 3 sticks in the first week,
ouch.
and took them back. And you know, the store was fine. I got new ones, and those have been fine. I ended up putting Ubuntu 22 on the SSD as GNU Radio 3.10 doesn't support Ubuntu 20. If you have to compile out of tree modules, they won't compile on 20 because the tooling is too old, the D packages and tooling. So 22 was fine, that worked, and I was able to compile it. So I've got virtual machines with 22, but the problem with virtual machine is I can't pass through the IO from GNU Radio to the peripherals on the computer. So I needed a real hard OS. And so that ended up working fine.
Well, I ran into a problem with Ubuntu 22, the serial adapter thing, the serial package for it.
Yes.
No, I mean, I've been using that to read the Adafruit Ultimate GPS so that I could get the lat long and the time in GNU Radio. And somebody posted a procedure to recover from this. It goes on for 4 pages of dense, all kinds of changes that you got to make, which when I have time, I might try it. But for right now, my grape is just going to have to make do with what it can get off of. You know, you have to key in what your lat long is and use some other way to get the time rather than getting it off the Adafruit GPS.
Yep.
So.
Well, I haven't tried the serial interface on 22, so I may not. It works fine on 20.
I find it amazing that they broke something that is that old. Who was even touching that code?
There may have been a developer who said, "What's the serial interface?"
Yeah,
Yeah.
probably.
Oh, I remember having a hard time getting a serial interface working on version 20 as well.
Oh,
I
really?
remember having to do a bunch of stuff to it, and I'd kind of forgotten about that, but I was rudely reminded of it.
Okay, were you using an actual serial hardware interface, or were you using one of the USB serial adapters?
No, it wasn't USB serial adapter. It's whatever Adafruit uses when you plug it into the Raspberry Pi GPIO. I think it might be I2C, a simulation of of the serial board or something, it uses TTY ADA 0, TTY AMA 0, which
Okay.
is, yeah, it,
Yeah,
fortunately,
the
it's kind of
Raspbian had a bunch of custom driver stuff
Yeah.
in Raspbian, you know, and it's possible that hadn't been cleaned up yet in the Ubuntu for Raspberry.
Well, yeah, I mean, I'm using Ubuntu 22 rather than Raspbian, but because there's some other things that are not available for Raspbian that I need to run the grape for digital RF and all that mess. So it's
Yeah.
interdependency hell.
I used Raspbian for my VLF capture system, and I use AMA 0 for a console port. So that's how I have it configured. And to talk to the GPS, I use a USB serial adapter that's built into my interface board. And I never really haven't had any problems. I'm currently having problems with the GPS now. I don't know if it's the actual GPS or the interface board, but yeah, everything always worked well, and I always had console access. On my 3-channel system, I also have an extra RJ45 for a Cisco console cable. So I have console access, but that's just how I do things. I like serial console access. I guess I'm used to that from the olden days.
Yeah, well, the Adafruit GPS is a hat which goes on the Raspberry Pi, and so you can't talk to it using a USB serial adapter. It assumes it's going to be plugged in, and anyway, we'll probably get it with enough time and energy put in it. I just didn't have the 6 or 8 hours to devote to it yet.
Yeah, you know, Dave, this brings up a general point. It may be worthwhile considering a way to take a well-known virtual machine disk image, right, and archive that,
Yes.
right? And then, you know, in the future, if someone needs to work on it, they could, you know, download the disk image and bring up a virtual machine that's of, you know, the operating system of the exact version with the exact version of the tool chains
Yes.
and, you know, the Java 8 mess and all of that stuff, all built into that disk image. I don't know if GitHub can archive a virtual disk image. It may exceed some file size or something. I don't know.
Oh, but
Something to think about.
one of the main storage places could, Amazon S3
Yeah.
or any of those.
Okay.
You just drop it in as a bucket and it just stored long term. You could put it in their lowest tier and, you know, pay pennies a month.
Yeah, if it's a common virtual disk image, that would mean a lot of different developers would have access to, you know, they could download it, run it, and, you know, perhaps increase their chance of success.
Yes.
Well,
I think
that is
that's-
how I distributed the grape image with GNU Radio and all that stuff to the couple folks that have been working with it. I take an image and upload the 3 gigabytes or whatever it is to UA Box, and then give people an access to it as a share.
Okay.
Because I can't think of any other practical way to do it, because you have to do so much customization to the OS. It's really not practical to give this to the app. You have to be a real hacker to get it working, and it's not a lot of people are not going to be able to get it working.
Yeah.
Okay, well, that's something for us to think about. It might make things go a little smoother in the future.
Okay. Yeah, I think that's a good idea. I'll catalog the idea and make sure that I do some background work. Find out best practices.
Bill, did you get GPSD to talk to that Adafruit GPS?
GPSD?
Yeah, GPS daemon.
I'm sorry, I'm not familiar with that. I was just, what I was doing was I was getting the, I wrote it's a Python module that runs inside of GNU Radio to talk to the Adafruit GPS.
Oh, okay. Because so GPSD is a daemon that runs in the background that will talk directly to your GPS. It supports several different, many different GPSs, Trimble, uBlocks, Garmin, all the, I have been contributing to the Trimble development. I've been giving engineering samples to the developer. But what it does is it allows you to use network sockets and shared memory to access GPS data. So for example, if you have GPS daemon running, it outputs, it will format JSON data that could be sent to some requesting client. It's actually really useful because it takes all the issues with using a GPS and talking to it. It takes care of all that and presents all of that data in an easily accessible format. And if you and it can also be used for timing as well, because it can take it can read pulse per second signals from whatever driver, and it can pipe that to shared memory that NTPD could use, and it will also discipline your system clock as well. So it's actually very useful overall. And if you need a GPS location or anything like that, you just pull it over the over a socket, and you get exactly what you need. So I've been using it for many different years, or for many years, and it just makes working with a GPS very easy, and you don't have to worry about all the extra stuff and drivers and things that you have to deal with to get GPS working right.
Well, but you're probably talking about a GPS that costs more than $40.
Well, no, it'll work with that, um, many different ones. I believe the one from Adafruit, I think that's like an MT part number. It supports NMEA, and it also supports the extra NMEA sentences for that MT part number as well. And I've had it working with a $240, brand new Trimble L1, L5 receiver as well. So it's very versatile with the cheap ones or the expensive ones. It just depends on if you have a driver. Trimble was always a challenge because it was never properly documented, and they didn't have enough engineering samples. But with uBlocks and others like the Adafruit one, there's a lot of support. And
Well, I mean, the problem in my case has been getting a serial connection to the GPS to work. Dealing with the data coming out of it is trivial compared to that. It's at some low hardware level within the operating system connection into the device itself. Now, I mean, maybe there's a way that you could wire something to the Adafruit and then connect that to a USB serial, which I guess you'd have to maybe cut the pins on the GPIO so to isolate it from the GPIO of the Raspberry Pi, and it would, I don't know if the hardware, if the voltage levels would be right for the serial, probably not. I don't know. I mean, it's a significant project to interface that. I mean, if you know better, I'd love to see the engineering diagrams of how one would do that.
Well, so I'm not familiar with the issues with the AMA0 serial port and Ubuntu 20. Normally, at least in Raspbian, it just works. But what you could do is you could download GPSD and you could give it a try. It's a simple command line program. You basically run the daemon and you give it a the simplest way is to give it the device path, so dev /tty AMA0, and if you run it in debug mode, you can see what's going on, and you could see it actually trying to talk to the serial port. It'll do something called auto baud. It'll automatically determine the baud rate. That doesn't always work perfectly. Sometimes you have to set those options when you set the device path. But yeah, if Autobot doesn't work, then you just set the serial port and you're good to go. Now, to run the debug, you would just run -D and say debug level 3, and that'll show you what's going on if it's actually talking with the GPS.
And Nathaniel, I put a link to the GPSD website, so for people that are curious, they can read more about it.
That's great. Thank you.
And it comes with different clients too. That's sometimes a separate package. When you download it from your Linux, just your packaging system, if you compile the source, it'll compile the clients too. The simplest client, CGPS, is a console GPS client, and it gives you all of the information from the GPS, as long as GPSD is running in the background and actually talking to the GPS. So it's a great tool to actually verify that that it's actually working too. So, but I use it on my VLF SDR on the Raspberry Pi. I use it to discipline NTPD. So I use it for timing.
Well, it's certainly worth a try.
Yeah, I'd be interested to know of your results. It's because I talk with the developer on a regular basis on IRC, so I could pass along any issues or problems too.
Yeah, well, I can't make any commitment on when I'm gonna have a chance to look at this. But I'd like it if somebody would. I've got a couple of Adafruit GPSs here. I'll send somebody one in the mail and they can plug it onto a Raspberry Pi. And if they can get it working under Ubuntu 22, that'd be great. I just don't think I'm gonna have time to do it.
Can you post a link in the chat for the directions on how to get the AMA00 port working?
There is if I think let's see here. There's a lengthy thing in Stack Exchange.
Yeah.
About halfway down through the Stack Exchange. Right there.
Oh, okay.
It's about, okay. It's the second answer. If this is the one, let's see. I think this is the one that I had identified as a possible thing to try. But this talks, bear in mind, this talks about Ubuntu 20.04, and we're talking about Ubuntu 22. But if GPSD obviates the need for all of this, that'd be great.
I mean, well, so one thing that I noticed here, so the first thing it says, enable _UART equals 1 into boot.config. That works for the Pi 3. So oh, I see. Okay.
Yeah, I don't know if this works, what I just posted here. It's just the only thing I could find that appeared to have an approach of how to go about doing this. So I don't know if this is a valid approach for the version of Raspberry Pi and the particular OS that we're using. But
Well,
it's really the only thing I could find.
Which version of the Adafruit GPS are you using?
It's called the Adafruit Ultimate GPS Hat.
So when you tried to do this, did you actually disable the console port?
No, I didn't get as far as trying this procedure. When I came across this, I said, okay, I'm going to put this aside for another day, which could be probably 2 months from now. That's as far as I got.
Okay, yeah, because I believe the console port is enabled by default. It is on Raspbian and I believe on Ubuntu as well. It's enabled by default. So if it's enabled, obviously it's in use, and you're not going to get any sort of communication. So you have to disable that first. Once you disable the console port with then you should be able to access it, and you shouldn't have any problems.
Yeah, that sounds familiar. I mean, it was like over 2 years ago. I did a procedure that was kind of in this direction to get it working under Ubuntu 20. I just haven't had this is going to take some time because you got to be careful you don't disable other things, whatnot. But anyway.
And I can't really try it because I don't have any Pi 4s. I only have Pi 3s. But even on a Pi 3, the console port is enabled by default, and so if you do want to use that serial port, you have to disable that first.
Right, that makes sense. So anyway, we'll come back to this when, because using the Adafruit GPS hat on the grape is kind of a nicety. You can get by without it. It gets you good lat long and a very precise time, but you can get by without it. I mean, I've even got code in the Python code. If the Adafruit GPS doesn't respond, I get the data from somewhere else and just print a warning. So
Yeah. So yeah. Well. So yeah. Timing is a whole other thing, because there's many ways to do it, and usually the best way is to interface the pulse per second signal somehow with NTPD, and that way you'll have your most accurate time. So that's what I do. Well, when it's working, it's not working right now, but when it is producing a pulse per second signal, that goes right into the PPS device, and through GPSD, it reads that um, that pulse per second device and writes each timestamp to the to shared memory, and then NTPD uses the shared memory driver um, to get those timestamps and discipline itself with a minimal amount of lag. There are different drivers in NTPD that you could use to um, actually get a pulse per second timestamp from different places, but one of the lowest latency ways to do it is to actually use GPSD. So yeah, I remember we talked about that sometime a while ago, because I was wondering how you actually did it, and I think you used the NMEA sentences to actually discipline NTPD, which there's a little bit of lag there.
yeah.
I'm gonna say 73 since I'm getting up early tomorrow.
I am too. Yeah,
Yep, same here. I'm gonna cut out.
but it's been useful.
Yes. And
Very interesting
Jonathan,
discussion.
we'll have to talk more soon. Okay.
Okay, sounds good.
Great.
I
Thanks,
assume everybody
everybody.
saw Bill Gibbons' timing measurements, which were kind of interesting too.
Oh yes. Yeah, John Gibbons.
John Gibbons, right? Yeah.
Yes, definitely. All right. Have a great night.
Night.
All right, have a good night. 73.